All right, in lesson 2, we're using statistical experiments. We're going to go over some vocabulary and then we're going to find some probabilities and determine if they are theoretical, which means just find the possibilities of what is expected outcome. Okay, so think about like flipping a coin. What's the probability of landing on heads? You would just say 50%, right? Because one's heads, one's tails. So out of the two outcomes, you're going to get one of those, right? So that'd be 50%. Same thing with rolling a six-sided dice, right? There is 1 through 6 on there, so probability of getting a 1 would be 1 out of 6, right? So that's theoretical. So probability based on what is expected to happen, based on your number of outcomes divided by outcomes divided by what you want to happen, okay? So that's probability. What you want to happen or um, out of what can happen. Okay. Experimental probability is actually flipping the coin and seeing what you get, right? So flipping the coin and gets heads. If I get heads and I want heads, that'd be 1 out of 1. I flip the coin again, I get heads again, that would be a 2 out of 2. I flip the coin a third time, I get tails, that'd be a 2 out of 3, right? So experimental is actually doing it and actually doing the experiment, okay, and actually flipping the coin or rolling the dice or drawing a card or whatever you have you. So probability of a model is a mathematical representation of a random event that consists of the sample space, and the probability of each outcome. So I list what I'm looking for, so like heads or tails, okay, and then how many times I get heads and how many times I get tails, and then the total number of the probability of each. So I give the probability. So I got heads 2 times, I got tails once. So the probability here would be 0.67, where this would be 0.33, right? So I list what my outcomes are, what the sample space is, and then the probabilities of each of those happening, okay? And then simulation is actually running through and kind of doing an experiment, um, and then kind of using that to go even farther. So that's what a simulation is. It's using the probability model to imitate the process of a situation so it can be studied. So drawing it further. So it's kind of more than experiment. It's actually taking those probabilities and running them further. So instead of flipping the coin actual 300 times, you run a simulation that will kind of automatically do it for you, and it'll just take your probabilities either that you found from the experiment, or it'll take your theoretical probabilities and show you what happens. All right, so let's go ahead and see if we can determine if it's theoretical or experimental. So again, here's a little theoretical probability explained, and experimental probability explained, and theoretical probability explained. Okay, so here's our question. So we toss a fair-sided 8-sided dice, okay, and we roll it 200 times and record the results. So if I actually do it, is it theoretical or is it experimental? So theoretical probability is what's expected to happen. So I'm expected with an 8-sided dice that I would get a 1 out of 8 for a 1, a 1 out of 8 for a 2, a 1 out of 8 for a 3, and so on, right? For each number, I'd get 1 out of 8. Well, what actually happened? Well, when I did it 200 times, I rolled a 1 28 out of 200 times, a 2 19 out of 200 times. So is that really 1/8? Right? So it's going 28 divided by 200. Is that actually 1/8? No, that's actually not 1/8. That's actually about 0.14, when 1/8 is 0.125, right? So this would be experimental. Okay, so this one is experimental probability because I actually did the flipping of the coin. So that's kind of the basic idea of how to tell the difference between theoretical and experimental. And so this question asks, what's the probability of rolling an 8? Well, normally theoretical would be 1 out of 8. Here, rolling an 8, we get 42, so 42 out of 200. Do the math is about 0.21. So 0.21 or 21%.